Welcome to the 7th video of the series JavaScript functions. In this video, we will learn about iterators and generators, a powerful JavaScript tool that helps you manage the data flow. In this, we will learn how iterators let you iterate through custom objects and generators give you the ability to pause and resume the execution. By the end of this video, you will have learned the following. Starting with the iterators, we will first understand the concept of iteration protocols, which are Iterable protocol and Iterator protocol. We'll get to know the purpose of Symbol.iterator, @iterator, and the next method. Finally, we will implement an iterable iterator on a user-defined object in two different ways. Coming to the generators, we'll start with understanding the concept of generator and how it pauses the execution of a function. What is the purpose of keyword like function star? We will learn to declare a generator function and how to do this in an object and in a class. The concept of generator object, yield and yield star statements, and conclude by implementing generator objects to get a good grasp of the concept. If you're completely new to the topic of JavaScript functions, I suggest you watch the playlist to understand the various topics in this playlist. The link is in the description below. And before I start, a short introduction about myself. My name is Sunil Kathuria and I have been in IT industry for over 20 years. I have developed skills in languages like C++, Python, JavaScript, and yes, English and Hindi for efficient delivery of my sessions. I have learned various software engineering skills like OOP, DSA, solid principles, and design patterns. I have also got my hands dirty on web frameworks like Flask and Django. I'm very passionate about distributed systems and eager to share my knowledge and help others start their learning journey in these exciting fields. I've been a technical trainer since 2020 and I try to make my technical sessions engaging, enjoyable, and accessible. We will start by understanding some basic concepts which will lay the foundation for implementing the iteration protocol. The first is iterables. Look at this code snippet where I write a code to iterate through a string character by character. And in the second code snippet, I'm iterating all the elements of an array one by one. Now it is possible because these two data types are iterable. Now look at the snapshot of the code snippet. Here I define a class book collection which maintains a linked list of books, and each node of the linked list is an object of class book. And I intend to iterate through this collection of books and print each book and author name using the for/of loop, the way I have been able to iterate through an array or the string a few minutes back. Unfortunately, when I try to do this, JavaScript throws an error stating that the book collection is not an iterable. And by the end of this video, we will understand what it takes to make this book collection class an iterable and implement the relevant code. For an object to be an iterable in JavaScript, it must speak the language of iteration protocols, the Iterable protocol and the Iterator protocol. We start with Iterable protocol. It is a mechanism for defining an object's iteration behavior. It allows using a for/of loop to iterate through an object. String, array, map, and set are some of the built-in data types that support iterable behavior. Now, to implement an iterable protocol in a user-defined object, the object must implement a method defined with Symbol.iterator. Now, this makes an object iterable, and the method as per the iteration protocol takes no argument. @iterator is an internal representation of Symbol.iterator, and the method we define using Symbol.iterator, JavaScript internally identifies the method using the @iterator and uses it to iterate over an object. In the code snippet, I define an object named SomeObject, and I define a method using the name Symbol.iterator, and the method as per the Iterator protocol takes no argument. Now we will learn about Iterator protocol. The method as per the Iterator protocol defined using Symbol.iterator we already know takes no argument, and it must return an iterator object. Now but the question is, what makes an object an iterator object? Well, the returned object is considered an iterator object only when it implements the next method. Let's see what the next method is. So JavaScript calls this method repeatedly to iterate over elements, and each call to this method returns two properties. First is the value. It is the next value in the iteration sequence. Second is the done, which is a Boolean variable. This indicates whether the iteration is complete or not. A false value indicates that there are more values in the sequence. True indicates that the sequence is complete. Note, both the properties are optional. When not defined, the value is set to undefined and done is set to true. The following pseudocode explains the functionality of the next method. When the next method is called, it checks for the elements to iterate. So as long as we have the elements to traverse, the method returns the two properties with the relevant data and the done attribute set to false. And when there are no elements to iterate, the function sets the value to undefined and done to true. This indicates the for of loop to stop the execution. Now we will see how to implement an iterator object, and this can be done in two ways. In the first instance, when an object's Symbol.iterator method returns this, it is called an iterable iterator, and the object itself implements the next method. In the second instance, an object's Symbol.iterator method returns an iterator object, and this iterator object implements the next method. We will implement the iterator protocol in both the ways, and we will use our book collection class. I start with an iterable iterator implementation. So in this example, I will maintain a collection of books in a linked list. Each node of the collection is an object of class book. And the object of this class stores the book and the author name. And in addition to this, it also maintains a reference to the next book in the collection using the next attribute. Now I start with the class book collection. Now this is my iterable iterator, which maintains a collection of books on a linked list. And in this class, I will implement the method identified by Symbol.iterator and the next method. And this class has two attributes. The first is the books, which acts as the head or the starting point of the linked list. And the second is current book, which is used to traverse through the linked list. Now I write the method add new book. Now this method accepts two arguments, the book and the author's name. Using this information, it creates a new object of the class book and adds it to the linked list. Now we will see the implementation of the method identified by Symbol.iterator. So as per the iteration protocol, this accepts no parameters and returns this, which makes the object of book collection an iterable iterator. Now one important point is, I have initialized the current book attribute to refer to the first node of the linked list, which is the groundwork needed to start the iteration. We will use this in the next method to traverse the linked list and maintain the state between successive calls. Since we are implementing an iterable iterator, the class book collection also implements the next method. With every invocation of the method, the value of the attribute current book is checked. If it is not at the end of the list, the method returns the book details, which are the book and the author's name, along with the done flag set to false. Otherwise, when it reaches the end of the list, it returns undefined with the done flag set to true, which is an indicator for the for of loop to stop execution. With this, I complete the code of the iterable iterator. And in this code segment, I test this implementation. And I start by creating an object of the class book collection. And then I add a few books to the collection. Finally, I execute a for of loop mentioning the object of the class book collection to iterate through the list of the books. Now I will implement the iterator protocol and make the changes in the existing code. To start with, I will remove the current book attribute from the constructor as it is not needed in this class, and the add new book method of the class will not change. The method identified by Symbol.iterator, instead of returning this, it will now return an iterator object. The iterator object in turn implements the next method. So the next method will move from the book collection class to an iterator object. I will write a new class that will act as an iterator object. Here is the updated code of the class book collection. Notice the Symbol.iterator method. Here it returns an object of the class book collection iterator, which is an iterator object. Now we will see the implementation of the class book collection iterator. When the Symbol.iterator method creates an iterator object, it passes on the reference of the linked list, and the class book collection iterator has an attribute current book which refers to the first node of this linked list. We will use this attribute to traverse through the linked list. The second is the next method. If you observe closely, it is the same as what we wrote in the earlier implementation. It has just moved from the class book collection to the class book collection iterator. With this, I complete the code of iterator protocol, and in this code segment, I test the implementation. And I start by creating an object of the class book collection. Then I add a few books to the collection. Finally, I execute a for of loop where I mention the object of class book collection to iterate through the list of the books. The question that I still have in my mind is, why do we need these two different implementation styles? Well, one reason could be that they make a difference when we want to use multiple iterators on a single user defined object. So to get hold of an iterator object of my book collection, I execute the Symbol.iterator method. So once I execute this method, it returns an iterator object. And once I have an iterator object with me, I can manually call the next method to iterate through the collection of books. Now if I need two iterator objects, I can execute the method Symbol.iterator again, which will return a new instance of an iterator object. Now since I have two separate instances of an iterator object, I can use these two independently to iterate through the collection of the books. They do not interfere with each other. To summarize, when I need two or more iterator objects to iterate through the elements of a user defined object without interfering with each other's sequence, in that case the user defined object must return an iterator object. Now when I have a user defined object which is implemented as an iterable iterator, which means that the user defined object implements the next method and its Symbol.iterator method returns this, which refers to the object itself. In that case, it should not use more than one iterator object to iterate through the elements manually. The reason is, since it returns this, which is a reference to the object itself, both the iterator objects will refer to the same current book attribute to get hold of the next element in the linked list, which causes interference between the iterator objects. You can observe the next method call from both the iterator objects is printing the book details in a sequence as if only one iterator object is used. With this, I wrap up the video. Considering the duration of this video, I will release a second part of this video where I'll cover generators. Let's summarize what we have learnt in this video. Thank you for watching this video. If this video has helped you, please like it. If you think this can help any of your friends, do share it. And finally, do subscribe so that you don't miss any other videos in future. Thank you very much. Keep learning.